Okay, I'm Don Porter, and I will be presenting an overview of the Graphene project. So, and disclaimers. So, I am a technical advisor to Fortanix and have a significant financial interest in their success. So, you can take the rest of my presentations with a bit of a grain of salt with respect to Fortanix. This work has also been supported in part by the US National Science Foundation, VMware, and Intel. Um, Anything that I'm presenting is my own opinion, not necessarily reflective of the views of any of these companies or organizations. Finally, as I'll explain a little bit and is more well documented on our website, graphene is not ready for production use. We are working to get there soon, but there are some significant security disclaimers to take note of before using this in production. At a high level, Graphene is a library OS or unikernel designed to run unmodified Linux application binaries on other platforms. The current focus and primary interest in the project has been in the context of bringing up application code inside of SGX, but the project is intended to be more broad than that. In the SGX world, we take a pragmatic approach. There's one school of thought that we think has a lot of value, which is that to get the most out of SGX in terms of performance and security, in the long run, it's probably the best thing to rewrite or significantly overhaul your application. However, in this project, we don't want the perfect to be the enemy of the good. And there are a number of cases where getting existing code running in SGX quickly can be a net improvement for security or a useful building block for a research project. So again, the target of Graphene is to run unmodified application code in SGX with minimal difficulty. Graphene is an open source project released under the LGPL, and overall, it's a software experiment in progress. So how does Graphene work? At a high level, what Graphene does is it re-implements the Linux system calls on a smaller ABI. And the idea is that if we can implement this small and simple ABI on any system, the rest of Graphene will just work. So for instance, suppose we want to run Apache inside of an enclave on an untrusted host. We use the Graphene library OS to implement all the standard system calls like open, read and write, and so on as an application in the enclave or application address space. And this is how we provide Linux functionality. That library OS is then implemented on top of a platform adaptation layer and a shielding layer. This provides portability as well as some semantic checks for these more narrow interfaces to the host. In total, in SGX, our platform adaptation layer is implemented using only 36 relatively straightforward OCalls, as well as 2 additional ones for debugging in non-production builds. And again, the vision is that if you can support these 36 calls on another platform, the rest of Graphene should just work. So a unique feature of Graphene is the ability to support multi-process applications. So suppose we want to run 2 Apache processes. In Graphene, we create 2 enclaves or 2 application address spaces, 1 per process. And this includes 2 copies of the running library OS. Shared OS abstractions are implemented in user space in a decentralized manner. None of the specific idiosyncrasies of Linux signals or System 5 IPC or fork or exec are assumed to be supported on the host. So for instance, if Apache wishes to issue a signal to the other process, it creates a remote procedure call using a secure channel that's bootstrapped in part by CPU attestation and key exchange, and this channel is secured. We support Unix abstractions including fork, exec, most System 5 IPC, and signals, again, all in user space and without any assumptions about shared memory between these enclaves. Graphene is a growing project. I'm delighted that we have a growing maintainer community of individuals, institutions, and companies contributing effort to both the overall maintenance and direction of the project, as well as code contributions to the project. We also have a growing set of well-tested applications, including machine learning frameworks, databases, web servers, and programming languages. Overall, the current focus of the project to date has been on stability and functionality. So if you tried Graphene a few years ago and you try it again now, I hope that you'll find, commensurate with other feedback we've gotten, that there's been significant improvements over the last year. The main reason that we don't consider the project production ready at this point is because there are some documented security issues where we need some additional time to work through. We released version 1.1 this summer, which includes a number of features, including improvements for remote attestation, a protected file system, support that you'll see later in the tutorial about making it easier to deploy Graphene in containers, exitless system calls, and support for Ubuntu 20.04 and the DCAP SGX driver. Project is on is that we hope to have a production ready release by next fall, if not sooner. Again, we have a set of documented issues that we're working through, but at a high level where we feel the project is that it's ready for people to play around with. The functionality is there. And I think you could start building applications on speculation that the security issues will be addressed by the time you're ready for it. The goals for the next year, beyond this sort of high-level goal, include extended support for network shielding, EDMM, or Enclave Dynamic Memory Management. We're going to continue looking at performance issues, including scalable multi-threading. There are some specific features that some language runtimes require that we will implement. And we want to improve the tooling and documentation, as well as rewriting a few of the less solid components of the system. In summary, Graphene is an open source, community maintained SGX platform for running unmodified Linux applications, as well as other Linux code. It supports a growing and rich set of applications, and we hope to have a production release coming soon. Thank you.